Welcome back to the subject Object-Oriented Analysis and Design. Today's topics are Gang of 4 design patterns, types of gangs of 4 design patterns. Coming to this gangs of 4 design patterns, as the name suggests, so this is an pattern introduced in a book. The book name was Design Patterns, Elements of Reusable Object-Oriented Software. Authors by Erich, Richgard, Ralpa and John. So providing a catalog of providing a solution to common design problems in software development. So as the name defines that, there are the 4 authors who introduced a book called Design Patterns, that is an elements of reusing the object-oriented softwares. So because of the book was designed by 4 different authors, so the name was suggested as Gang of 4. So this pattern encourages best practices, code reusability and the separation of concerns, aiding in the development of robust and scalable applications. So this is a very best book for designing patterns. So coming to the types of gangs of 4 design patterns. So these patterns are set of 23 common software design patterns introduced by the authors, and that 23 common patterns are again categorized into creational patterns, structural patterns and behavior patterns. So these patterns provides a solution to common design problems, as I said, and helpful to make the software system more modular, flexible and maintainable. And coming to the first patterns, which are the creational design patterns, focus on the process of object creations in software development. So as we know that in object-oriented design models, almost all the structural patterns are defined based on the objects. So here also we can see the creational design patterns focus on the process, how they are going to be communicated, how they are going to be define the features, extracting the features from one class to the other class. So totally these creational patterns are depend upon object creations in the software development. So these are the patterns which comes under the creational design patterns. The first one is a factory method pattern. The second one is a abstract factory pattern. The third one is a singleton pattern. Fourth one is a prototype pattern. Fifth one is a builder pattern. Sixth one is a object pool pattern. So let us discuss one by one. Coming to the first one, factory method pattern. So this pattern defines an interface for different subclasses that can create the objects of different types using the same method. So as we know that in a class diagram, if there are a multiple types of classes, among these classes, these factory method patterns are helpful to interface between the subclasses, and then they create the objects of different types related to the same methods. So whichever the related to the same methods are going to be categorized into one class. So coming to the second one, abstract factory method. So this is going to be, for example, imagine that you are in charge of fancy dinner party, and if the person is going to be manage the whole things, like you need to matching the tableware as well as the curtain and decorated things. So this abstract factory is like one stop for all these related items. So that is nothing but there is no need of going to the different locations to collect the elements which are related for an party or for an function. So everything can be collected from a single person. In the same way, so this factory pattern method is helpful to collect all related, which is going to be creating the similar type of objects. So all the objects which are family type of or related to a type of objects are going to be collected at one point. So ensuring that everything you create fits together seamless. So that are going to be fit in a single class. Coming to the next one, singleton patterns. So it ensures that a class has just one instance. So one instance is nothing but like having a VIP pass and to a club. You can access that instance from anywhere, making it handy for suitable situations where you want to single point to control and coordinate in your applications. So this is working like an controlling the overall working of the each and every model. So these patterns are helpful to having a control on access all the models. Coming to the next one, prototypical patterns. So the name says that an order. So here it is nothing but instead of creating something for scratch, you may have a copy of an existing one, saving time and resources, because it is having a link and existing all the related previous one and the next one. It is having all the related elements, so it saves the time to collect the information. Next one is the builder pattern. It helps you creating the complex things step by step, one piece at a time, without worrying too much about the details. So this is a builder pattern which is having the whole information relating to the patterns. So the next one is the object pool pattern. Keeps the collection of objects like database connections or threads and hands, whatever the things that are related to that, it is going to be collected in one pool. So this saves the time and resource comparing to the creational and destroying the objects frequently. So these are the different types of patterns which comes under the creational patterns. The next one is the structural patterns. So the structural patterns, these are the adapter pattern, bridge pattern, composite pattern, decorator pattern, facade pattern, flyweight pattern and proxy pattern. So as we had seen that creational patterns, in the UML diagram also we are having the structural and behavioral patterns. In the same way, here also a group of patterns which comes under the structural patterns. So when we talk about the structural patterns in the UML models, we are having the class model, prototypical model, whereas the package model and deployment model, all these models comes under the structural models under the UML models. But here, as the authors are defined, so these are the patterns which comes under the structural patterns. Coming to the next one, behavioral patterns. So these are the behavioral patterns. Even we had discussed that under the UML models, the behavioral models will represent like flowchart models, like having a sequential model, use case model. All these are the models which comes under the behavioral model. So that under the UML models, as we know, a group of related models which comes under structural and some group of patterns which comes under the behavioral models. So here also we are having the models like chain of responsibility pattern, command pattern, iterator pattern, mediator pattern and memento pattern, observer pattern, state patterns, strategy pattern, template method pattern. So if you see here, each and every pattern which comes under the behavioral will represent the behavior of the objects which are defined in that particular models. So here, as we know that this is a simple topic you used to understand that there are 4 authors who had designed a book called Design Patterns, Elements of Reusable Object-Oriented Softwares. Under this book, they are totally defined 23 common software design patterns introduced to the people who can easily understand the design models. So here they are categorized into 3: creational, structural and behavior. Whatever the 23 common software design patterns are there, which falls under the creational, structural and behavior. So depend upon the requirement, the developer can define the creational, structural and behavioral. So they can choose any one of these patterns to develop the software. So this is all about the GOF, which is called as a gang of 4 design patterns. Coming to the next topic, introduction to the GRASP. So this GRASP is nothing but which comes under the object-oriented analysis and design, which is a general responsibility assignment software patterns. So this is also one type of patterns, just like an object-oriented analysis and designs, which we had seen all in the previous classes. At the same time, the previous topic, which is called as a gang of 4 patterns. So in the same way, this is also a type of design patterns. So plays a crucial roles in designing effective and maintainable software systems. So by understanding and applying these GRASP principles, developers can create the software solutions that are flexible, scalable and easier to maintain over the times. Coming to the principles of GRASP, so these are the different types of principles that we can understand, which stands for the general responsibility assignment software patterns, including several principles that are: the first one is the creator, second one is the information expert, third one is the low coupling, high cohesion, next one is the polymorphism, indirection, next one is a pure fabrication, and the next one is the controller. So all these are the 8 different types of principles which comes under the GRASP patterns. Coming to the first one, creator. So which is nothing but responsible for creating instance of the classes to the class that has the most knowledge about when and how to create them. So this principle will define that when and how to create a class. The second one is the information expert, which is responsible to a class that has the necessary information to fulfill fulfill it and promoting high cohesion and minimum coupling. So which this information expert will use that when to couple or when to going to be cohesion. Like here the word coupling and cohesion is nothing but whenever you are going to combine more than one class, you are going to apply the coupling technique, and whenever you are going to based on the number of methods, you are going to describe that whatever the class it is, which is called as an cohesion. So this particular information expert principle is used to define when and where it is needed to perform the cohesion and coupling technique. So coming to the next principle, which is a low coupling, aims for the classes to have minimal dependencies on each other. So this principle is used to confirm the minimal dependencies because it is having the low coupling. So facilitates easy to maintain and flexible in the system. So that it is having the minimal communication, it is going to maintain that having the flexibility in the system. Next one is a high cohesion, ensures that the responsibility within the class are closely related and focused, enhancing the reliability, maintainability and reusability. So this high cohesion principle will take care of maintaining reusability of the classes. The next one is a controller, assigns the responsibility for handling the system events or coordinating activities to the controller class, promoting centralized control and avoiding the cluttering classes. So this is also used to control the overall classes. And the next one is a pure fabrication, introduce a new class to fulfill responsibilities without violating the cohesion and coupling principles, promoting clear and more maintainable designs. So this pure fabrication principle, which is used to add and or introduce a new class into the existing classes. So whenever a new class is going to be introduced to the existing one, they have to maintain that they should not raise any kind of problems in the cohesion or in the coupling or in the maintaining. Coming to the next one, indirection. So using the abstraction to decoupling the classes and promotes the flexibility in designing. The last one is the polymorphism, utilize the inheritance and interfaces to enable multiple implementations of the behavior, allowing for the flexible and extensible in the system. So all these are the various types of principles which comes under the GRASP, where by applying this GRASP principle, developers can create object-oriented designs that are robust, maintainable and adaptable to change requirements whenever they develop the softwares. So these are about the GRASP principles. Thank you. Hope you understood the topic.